In this video, I'm going to show you how to build simulation models. Please have the Arena teaching notes handy. I'm going to show most of those examples covered in the notes. So first of all, this is the Arena software. So when we built a simulation model in the past, it was pretty difficult because it was more about like programming. But today, with all these fancy softwares, things are much easier. So because everything's very user friendly. So in the past, it was about programming, but now it's really, it's really about putting things together. So everything's already pretty much pre-built. You just have to pick what you need and putting them together. It's more like assembling a product. So let's look at the whole window. And this is something called the project bar. Look at here, all these the yellow boxes. It's called a project bar. This is something we really need to build a simulation model. So what we really need is just click and drop. So pick what we want and drop in the middle window. This is called a workspace. We call model window. A model window basically means workspace. So you choose what do you need and drop it here and assemble them together. And this is called data module. We can use data module to edit some parameters. For example, edit the capacity, edit the schedule, editor, attribute something else. And then on top, we have a toolbar. Okay, so that's pretty much it. We have three things that are very important. We have special names. The first one is called an entity. Okay. So what is entity? Entity are the items that are being processed, served, and or otherwise acted on by our process. So basically means if you are simulating a manufacturing system, an entity can be a component, can be product, can be working process, talking about physical goods. But if you are simulating a service system, an entity can be a people, right? Can be a customer, can be passenger. So these are the units that flow through the system. This is called entity. Second term we call the attributes. So what are attributes? Attributes represent user-defined values associated with individual entities. So for example, customer type, arrival time, priority level. So if you're simulating an airport, most airports have priority lines for business customers, for premium customers. So how do you differentiate the two customers? One is general customer, one is a business customer. So how to differentiate? We can use attribute to differentiate different kinds of customers. The last one is about resource. So resource is basically talking about servers. Okay, so if you have 1 unit of resource, that means the number of server is 1. If you have 10 units of resource, that means the number of servers is 10. So these are some basic terminology. Now, let's work on the first example. In the first example, it's very simple. We're going to build a simulation model. It's very simple, very basic, and it will have one resource, or in other words, we have one server. So in this particular system, customer arrival time, the inner arrival time follow exponential distribution. The average inner arrival times actually, let me see, is 10 minutes. This is a given. And also because it follows exponential distribution, we know the coefficient variation is equal to 1. Then for service time, it also follows exponential distribution. And the average service time or process time is 8 minutes. So this is the system we're going to simulate. Of course, for a system like this, because it's so simple, we don't even need to build a simulation model. You can just apply the formulas we learned in topic 6 to calculate what should be the average wait time, what should be the average the length of the queue, right? So now we're going to build a simulation model to verify and see if the result from simulation model actually match the result from the analytical model, or in other words, from the formulas. So to build a basic simulation model, we need 3 modules, okay? At least 3. First one is called create, okay? Create. Second one is called process. The last one is called dispose. So pretty much all the models we see in this class will have at least 3 modules: create, process, and dispose. Well, you can have more, of course. Later you will see. You can have more if you want to build a more sophisticated system. So how do we add a module into our model? So as I said, these are the tools. All the modules are your tools. You have to choose and you click and drop. You put it in the middle window. This is called a workspace, right? So let's see, how do we add the first module? So create, I click and drop. So now I have a create module. This is one. I'm going to add a second one. The second one is a process module. So before I add, click and drop, before I add a second module, which is a process module, I want to make sure the first module is highlighted. So you look at these, all these dots surrounding this module is called highlighted. If I click somewhere else, this is not highlighted. Highlighted, not highlighted. So I want to make sure this one is highlighted. If you can make sure the first one is highlighted, then when you click and drop the second module, it guarantees that these two modules will be connected with a line. Okay, this is something we need. Okay, let me redo it. let's say if I forgot to highlight this one. Okay, before I click and drop a second module, which is process module. Well, what happened? If you forgot to highlight this module, I click and drop process. You see, these two are not automatically connected. In this case, you have to connect these two modules manually. So if you go to toolbar, you will see something called connect. Okay, so you click it. Then you click the first module here. Then you click the second module. Then it will be connected. So if you can make sure the first module was selected before you're adding a second module, then you don't have to do this. Okay, otherwise you have to do this manually. So now I have a create module, I have a process module. I need to add the last module, which is dispose. So as again, I'm going to highlight process module, and I click and drop. Okay. So now I have all three modules. This is a complete model. Of course, we're not done yet. We have to add some data, right? So now let's take a look. Okay, how do we do it? So first of all, before I do any edits, I want to save my model. So I have to click save. I already actually saved it. So if you really want to take a look, I'm going to do save as. You pick a folder and pick a name. In my example, I do, it's called example 1. You can see for all the Arena model, the extension, the file extension is DOE. So I have example 1.doe. I save it. Okay, I want to replace it. That's it. Okay. So this is our first model. Now we have to edit the data. So in this case, I have 3 different modules. The last one is less important. Dispose module is less important. Create module, process module are very important. For any simulation model, you need to specify the arrival process. In other words, the demand. So all the information related to demand, you have to specify in the create module. And all the information regarding capacity, or in other words, the process itself, you have to specify in the process module. Okay, so create module, it should generate customers. And customer will go to the process and then leave the system from dispose module. So you generate customer here, it goes through the process, and leave the system from here. So these are the basic 3 modules. So how do we edit? We start with the first one, create one module. So if you double click create one module, now we have a dialog box. We can edit information. First of all, we give a name for the module. The name is not something, it's only for informational. It's not something that will affect your result. So what's the name for the module? I will say it's called customer arrive. This is just for information. So when other people are looking at your model, it makes things easier. Then you have to pick a name for entity. Pick a name. So here we're simulating service system. So we can pick a name for entity, is basically customer. But if you are simulating manufacturing system, that you can say it's the component or products, right? Then next thing is so important. We are talking about time between arrivals. Time between arrivals. This is something we discussed in class called in the arrival time. customer in arrival time, the time between two arrivals. So in this example, we said that the time between two customers in arrival time follow exponential distribution, and average in arrival time is 10 minutes, right? So we need to specify the information here. So first of all, we specify the distribution type. There are different options. You can do constant, schedule, random, exponential, expression. So look at the first one. The first one says random exponential. So this is what we want for this particular example. As I said, for the first example, we assume the in arrival time follow exponential distribution. So we choose exponential. Then we do value. Basically tells the software what is the average in arrival time. So average is 10. Be careful about units. It's actually 10 minutes. Okay. So this is something that is very important. A lot of people forget about it. Okay, it's 10 minutes. Some people forget about it. The default is hour. So if you do 10 hours, that's different. 10 hours versus 10 minutes, it's a very different system. Okay. If you do 10 hours, you barely see any customers. That's why you have to pick the right time units. So it's the average in arrival time is 10 minutes. Everything else is just default. So this, now we're done with the create module. So now we move to step 3. We're going to do the process module. So double click, give a name. The name is called service process. Again, this name is also for informational. It will not affect the final result of your simulation model. And then one thing that is important is the logic. And for almost all the examples we do in this class, we're going to do cease delay release. Cease delay release. So we view a server as a resource, right? So whenever a customer needs a resource or needs a server, this customer is going to grab the server for a certain time period. It can be 10 minutes, it can be 5 minutes, right? It can be 20 minutes. So after 10 minutes, 20 minutes, 5 minutes, the customer is going to release the server. So that's why the action is called cease delay release. We have some other actions. We don't use it for models we cover in this class. It'll be used for something more sophisticated. So it'll be cease delay release. Then we also have to add a resource. So what kind of resource? We have to define resource. So we click add. So in this case, we're talking about bank. We're talking about bank. So resource name is Taylor. It's Bank Taylor. Quantity is 1. The quantity here, this one is not the number of bank tellers available. This is how many bank tellers each customer needs. And so this is different. So we have different place to specify the number of bank tellers available. It's somewhere else, not here. This number 1, that means each customer need 1 bank teller to help them. Okay, so it will be 1. For most of the service system, actually it's 1, right? Some special case you may need 2 or 3. So I click OK. So this specifies the resource. Then we have to specify distribution. So delay type, we have different distribution. Can be constant, normal distribution, triangular, uniform, but we need exponential. So if you look at drop-down list, we don't even have exponential. How do we do it? If you don't see the right distribution here, you can always use expression. So expression allows you to specify what distribution you need. Yeah. So I click expression. So under expression, I type EXPO. EXPO stands for exponential distribution. I put a 8 minute 8. So I have EXPO parentheses, and in between I have a number 8. That means average is 8. Be careful again. Time units, I don't do hours. The average service time or processing time is actually 8 minutes. 8 minutes. So that's it. That's it for second process module. For the last one, dispose. It's actually very easy. We just give a name. So we give a name. The dispose is called customer lead. Again, this is for informational. Okay, just click OK, informational. So save it. So we're almost there. Okay, this is our very first simulation model. So before we run simulation, we have to tell the software how much time we want to run simulation. Are we going to run simulation for 2 days or 3 days, 1 year? Okay, so you have to specify the duration of your simulation. Okay, so in this case, when we do the analysis, it's a bank. We're going to simulate the bank for 1 month. Okay, 1 month. So we think about, assume there are 4 weeks in each 4 weeks each month, and each week the bank teller work for 40 hours. So 40 hours a week, 4 weeks. So we're going to simulate altogether 160 hours, not 160 hours in real time, 160 hours in simulated time. So how do we specify that? You go to Run, click the menu Run, and click Setup. You see I have different tabs. The first tab I want to do is go to Project Parameter. So click Project Parameters. Give a title for your project. So I would say it's my first simulation project. So you can give a different name. So this is my first simulation project. Analyst name, M. Chen. That's my name. Okay. So this is for information as well. Okay, because you have the copyright. You are the one who's doing the building a simulation model. The project title and analyst name. Then we go to replication parameter. This is the most important thing. So we're going to do 1 replication. You can do more than that. You can do 10. Oftentimes we do 10 or even more, okay, to get a more precise results. I don't want any warm-up period. My replication length is actually 160. As I said, I'm going to simulate for 1 month. So 160 hours. I'm going to simulate 160 hours. Here we're talking about 160 working hours. So how many hours per day? Working days, 8 hours per day. The last number is base time units. So what is base time units? So this relates to your report. So every time you run simulation model, in the end, it will generate a report. In the report, it tells a lot of different metrics. For example, average wait time, or average length of queue, or utilization, something else, right? So it will generate a report. So it depends on how you want the report to show the results, right? So if you want a report to show results in minutes, then you choose minutes. If you want the report to show everything hours, then you choose hours. So it depends on what you choose here. You should interpret the results differently. So most of the service settings, I would say, I think that minutes is a good number. Okay, I do minutes. Minutes is a good number. I want to interpret everything in terms of minutes. Seconds is too precise and not necessary. Hours was too long. It's probably only appropriate for certain service systems. So for most of the service settings, I would say minutes are good. So I'll choose minutes. You can do hours, it's fine. Okay, it's nothing wrong, but make sure. Just remember, if you do choose hours, then when you read the report, everything should be interpreted as hours. Here I do minutes, that's why I will interpret everything in minutes. So that's it. I click OK. So that is my first model. Now it's an exciting moment. I'm going to run simulation. So how do you run simulation? You go here. You go here. This is called Go, right? You see this button. You click it, and simulation will start. Okay. See. You can control the speed by sliding the bar. Okay. Slow, fast. So you can slide the bar. You can control the speed of simulation. Make it a little faster. Let me see. So you can see the cues. You can see the cues here. Then now simulation is done. You see, simulation has run to completion. Would you like to see the results? Or in other words, do you want to see the report? I say, yes, I want to see the report. So this is a report. So go to the left-hand side. You will see a lot of things you can choose. So I want to see entity. I want to see time. So here I can look at 3 different times. So the first one is VA time. So what is VA time? Value added time. In other words, service time. So based on my simulation, the average is 7.85. That's the service time. So it takes about 7.85 minutes to serve each customer. In our simulation model, when we specify the average service time, it was 8 minutes. So it's close enough, right? Second number is called wait time. So based on simulation model, what is the average wait time? It's about 32.9, close to 33 minutes. Okay, so average-wise, customer have to wait for about 33 minutes. The last one is called total time. It's 40.8 minutes. The total time is total time spent in system. In other words, total time is the sum of service time and plus wait time. So this is about time measurement. You can also look at a queue. Look at here. Look at number of people waiting. Yeah, in other words, it's actually IQ, right? IQ. So how many people are waiting in line? So average-wise, you can see in this simulation model, we have 3.35. This is the average number of people waiting. This is something we can calculate based on formula. But there's one number we cannot calculate. Okay, so when we calculate the length of the queue, we can only calculate the average. But sometimes we're interested in, what is the longest queue? Okay, over 160 hours. So what is the longest queue we can observe? So if you use formulas, you cannot obtain such information. But if you use simulation, it's actually here. The maximum value is 21. So over 160 hours, the maximum number of customer waiting in line is 21. This is something we don't have when we apply the formulas. This is something that's only available by simulation. So minimum 0, maximum 21. Because sometimes there's no people waiting. The worst case, you have 21 people waiting, right? You can also see the utilization. So for the bank teller, the utilization is about 79%. Okay, 79%. So which is a little high. I would say it's a little high. They're not terrible, but a little high. So this is our first simulation. Let me ask you a question. So look at the average wait time for a bank. It's about 33 minutes. Do you think it's good or bad? So, well, I would say it's not good. It's definitely not good. If average-wise, people have to wait for about 30 minutes, it's kind of bad. So that means you have to improve it, right? You have to improve it. So you really have to figure out how to do it, okay? How to improve it. So now, I'm going to close the report. So you go here, you can close it. Then I can change my model to change the capacity. Because as I said, in the first example, we only had one bank teller, which leads to average wait time about 33 minutes, which is not good. So we may want to see how it works if we add more people. So we want to edit the model. So before we do any edits, make sure you have to end a simulation. So how do you end a simulation? You go to the toolbar, see the last button, it's called end. I click it. Okay, now you can edit it. Okay, so first of all, save it. And then I'm going to save this example as example 2 because I don't want to lose the information. I still want the original information. So I go here, click File, I do Save As. I don't want to lose example 1. I save example 1 as example 2. Okay, I save as a different file. Then I want to do some edits. So now we are in example 2. In the second example, we want to see how it works out if we add more people. Let's say we add 1 additional people. Remember, with 1 bank teller, the average wait time is about 33 minutes. So we want to see what if we add 1 additional bank teller, how things can be different. So what do you think? Some people say, the average wait time was about 33 minutes. So if we can add one more people, maybe we can cut down the average wait time by 50%, so make it by 16, 17 minutes, right? So a lot of people may suspect that. So we take a look. We don't know. Okay. So we want to see what will happen if we add one more bank teller. So now, how do we change the capacity? So you go to resource. So go to the data module, click resource. Once you click a resource, look at here, the bottom part. It says now I have one resource. It's teller, bank teller, right? It's a fixed capacity. So what is the capacity? Right now it's 1. So I want to change it to 2. So I double click, I'll make it 2. So type 2. So now instead of having 1, I have 2. So that's it. Okay? That's how we revise our model to increase capacity. Now I can run simulation again. I save it. I run simulation. So simulation has run to completion. Do you want to see the results? Yes, I would love to. So let's go ahead and look at time. Now you can see what's the average wait time. It's 1.25. It was about 33 minutes. By adding one additional bank teller, we can reduce the average wait time from 33 minutes to 1.2 minutes. That was amazing, right? This is something that's not very intuitive. So adding one more bank teller can greatly help the situation, can reduce the wait time dramatically. So this is something we need a simulation. We have to perform simulation to figure out, how the capacity will affect the performance, right? If you don't do simulation or don't do some analytical models, it's just very hard. It's not intuitive. It's hard to, if I ask you how, most people said adding more people, you can cut down wait time by 50%. This is not happening. It can actually a lot more than 50% dramatically. So now the average wait time is 1.25 minutes. I would say it's pretty good, right? It's pretty good. So, so I would say if you were the manager for that bank branch, you probably want to have 2 people, 2 bank tellers. That should be sufficient. So of course, with 2 bank tellers, the resource utilization will be much lower, right? It's only 37%. That means 37% time the bank tellers are busy with customers, and then the rest of the time, well, they don't have anything to do. So that's a trade-off, right? If you want to increase capacity, then the utilization will be lower. Wait time will be lower as well, right? So I'm going to close the report. This concludes the second example. So I end the simulation, I save it. So this is example 2. Now let's do example 3 and example 4. So example 3 and example 4 are based on example 1. So first of all, I want to close example 2. I open example 1. This is example 1. So in example 1, both service time and in-arrival time follow exponential distribution. So both have some variation. Arrival process have variation. Service process has some variation. And in example 3, we want to see if we reduce the variation, or reduce one of these variations, what will happen? In class, we learned that variation is one of the reason why it causes waiting. So if you can reduce variation, you can reduce waiting, right? This is something we learned conceptually. Reduce variation can reduce waiting. Now let's verify it. Okay, verify. So this is example 1. I'm going to save example 1 as example 3. So in example 1, I have 2 types of variation. Arrival has a variation, and also service has a variation. So now in example 3, I'm going to cut down the variation. I'm going to reduce the variation for service time to see what will happen. Why? I don't want to change anything about in-arrival time. Instead, I want to change the the distribution of service time. So I double click service process. So double click it. It was, in example 1, it was exponential distribution with average 8, right? So here, in example 3, I'm going to reduce the variation. So how do I reduce it? I want to look at one extreme example. So I want to make sure service time is exactly 8 minutes for each customer. So it means no variation at all. Okay. So I want to make sure service time is exactly 8 minutes for each customer. So delay type, I don't want to use expression. Instead, I want to use a constant, same number, constant. So how much? 8. So this means what? The service time is a constant number of 8 for each customer. So 8 minutes. So this is something I want to change. So I completely remove, eliminate variation for service time to see what will happen. I click OK. So remember, if we have, in example 1, we had both type of variation. The average wait time was about 33 minutes. Now we only have variation regarding in arrival time. We don't have variation regarding service time. So let's run simulation to see what is the resulting average wait time. Simulation, yes, I want to see report. Let's go here, look at here. So what's the average wait time? It's 14 minutes. It was about 32 minutes, right? It was about 33 minutes. Now it's about 14 minutes. It's much shorter because we just eliminate the variation for service time. Right? This is something expected. Close the report, end the simulation, and close. Save example 3. Then I close it. Now let's look at example 4. Example 4 is the opposite. Okay, opposite. In example 4, I don't want to change anything about service time. Instead, I want to change the variation for arrival time, in arrival time. So I want to completely remove the variation for in arrival time. So I go open example 1. So example 4 is also based on example 1. So I open example 1, save it as example 4. Now, I don't want to do anything about service time. It is still exponential distribution with 80 minutes. I don't want to change it. What I want to change is about customer arrival, okay, in arrival time. So in arrival time, in example 1, it was exponential distribution, 10 minutes. Now, I don't want to do exponential, I want to do constant. So constant 10 minutes, okay? That means there's no variation. Customer will arrive exactly every 10 minutes. So I click OK. That's it. I run simulation. So would you like to see the results? Yes. Look at the wait time now is 12.89. It was 33 minutes. Now it's about less than 13 minutes, right? Much shorter. So this is something, again, this is something we expected. By cutting down the variation, you can help the system reduce the average wait time. I'm going to end a simulation and save it and close it. So next I want to cover 2 more examples. Okay, in this video, I'm going to cover 2 more examples, which is example 5 in your teaching notes, as well as example, let me see, example 8, I believe. So 5 and 8. Okay, 5 and 8. So here we're going to simulate DMB with time-varying arrival rate and time-varying capacity. So this is a DMB system. So first of all, go to page 12. On your teaching notes, I'll give it you 2 minutes to read it. Okay, example 5 on top. So now let's look at example 5. It's a DMV. Okay, it's a simple case of DMV. So first of all, I add a new file. I save it. This is example 5. Example 5, DOE. So in this case, I have two kinds of customers. Some customers are looking for a driver license service. The other type of customers looking for vehicle registration service. So they will join different queues. They will be served by different agents. And the customer arrival rates are different. Okay. In all the previous examples, including examples we cover in class, we assume that arrival rate is same. It's constant, right? But here we have to deal with different arrival rate for different hours. This is pretty common, right? A lot of service settings, you have peak time and non-peak time, right? So here you see from 8 a.m. to 11 a.m., I have an average wise about 95 customers per hour. From 11 to 1, I have 125 customers per hour. 1 to 3, 100, 3 to 4, 30, 130. So this DMV office will close at 4:30. Okay, so nobody can get in at 4:30, but then the entire system they will shut the door at 4:30, but they will keep working until everybody leave the system. So the actual will close at 5 o'clock, but they will shut the door at 4:30. Nobody can get in at 4:30. Okay, so we're simulating simulation hours from 8 a.m. until 5 p.m. But after 4:30, nobody can get in. So this is about arrival rate. Same thing, look at the same table. You can also look at how many people are available. It's also different, depends on the time period. So let's build the model. The first model we need is create, as I said, always need a create module. The create model will create customers. In this particular example, we're going to learn something new. We're going to have a decide module, decide, because we have a separate customers. So we have two kinds of customers. So those who are looking for driver license service versus those who are looking for vehicle registration service. So we have two kinds of service. So how do we separate them? So how much percent? First of all, 60% of customer require driver license service, and then the rest require VR service. So to separate two customers, I use decide. So add a decide module. Okay, so do you want to go for driver license or for VR, for vehicle registration? Then for each decide module, typically I have two different branches. One goes to the right, one goes down. Okay, so if you're looking for driver license service, you go to the right. So add a process module. If you're looking for vehicle registration, you go down. I add another process module. Okay, add two. So this is a route for those who are looking for driver license. This is the one for those who are looking for VR service. And of course, afterwards, I'm going to need a dispose module. I need a dispose module. Okay, again, please make sure before you add the next module, please highlight the previous module. So these two modules will be automatically connected. Otherwise, you have to connect them manually. So now we have all the modules available. Okay, so this is the model. Now we have to define parameter. So we are at step 3 now. Okay, so we're going to step 3. So here we want to model something new. One is time varying arrival rate. In the past, in the previous examples, arrival rate is always given, right? Fixed the same. Now we have to model time varying arrival rate as well as time varying capacity. So how do we do that? If you have to model time varying demand, arrival rate or capacity, we have to use something called a schedule. So click schedule. So underneath here, right now it's blank. We don't have any schedule yet. So we have to define it. So how to find a schedule? Look at here, double click. I double click. Now I have a new schedule. But I have to define it. So how to define it? You can edit. Right click. So right click and choose edit by dialog. Edit by dialog. The first schedule we're going to do is called arrival rate. Arrival rate, is that capacity or arrival? Of course, it's arrival, right? Then time units, we're going to use hours. So let's look at here. The next, we have a box to fill. Duration. You look at the table on page 12, it says arrival rate is 95 from 8 to 11 a.m. So from 8 to 11 a.m., the arrival rate is 95. So the arrival rate is 95 cost per hour, which will last for how long? It will last for 3 hours. So I added the first duration. My arrival rate is 95. It goes from 8 a.m. to 11 a.m. That is 3 hours. So that's first time period. Second time period, I have 125 customers per hour. It lasts from 11 a.m. to 1 p.m. That means it lasts for 2 hours. The next one is 100 customers per hour, which will go from 1 p.m. to 3 p.m., which is 2 hours. And the last one is 130. How long it lasts? From 3 p.m. to 4:30 p.m. is actually 1.5. Okay, 1.5. Some people will stop here. Okay, we're not over yet because as I said, I'm going to simulate the DMV for 9 hours. So we still have one more, which is from 4:30 to 5. 4:30 to 5, the door is closed. So that means arrival rate 0. So which will last from 4:30 to 5, which is actually half hours, 0.5. So this is how we define the time-varying arrival rate. Given name, arrival rate, type is arrival, and make sure all the numbers are right. I click OK. Okay, that's the first one. Second schedule I want to define is the working schedule for driver license capacity. Right, driver license capacity is time-varying. So how many agents available to deal with driver license application or renewal? So double click to add a new role, and then right click, edit by dialog. The second one, let's give a name. It's called DL capacity. What's the type? Of course, the type is a capacity. It's not arrival. The first one is arrival. The second one is capacity. So we have to add duration. Look at the table on page 12. It says from 8 a.m. to 11 a.m. there are 10 agents available. So capacity is 10. It lasts from 8 to 11, which is 3 hours. That's the first period. The second period is 13 agents available, which goes from 11 to 1. That means there are 2 hours. The next one is 10 agents available. It goes from 1 to 3, 2 hours. And the last one is actually 15. It goes from 3 to 5, it's 2. Okay, so that's how we define the capacity, time-varying capacity. So 10, 13, make sure all the numbers are correct. So that's it. Close it. The last one, because we also need a time-varying capacity for a vehicle registration service. So double click, right click, edit. For this one, we give a name as well. So it's called VR capacity. This is called capacity. The first one is 8 people available. It lasts for how long? 8 to 11, that's 3 hours. Then we have 12 agents available from 11 to 3, which is 4 hours. And the last one, we have 15 that goes from 3 to 5, which is 2 hours. So 3 different time periods. So that's how we define schedule, okay? Whenever you deal with time-varying capacity or time-varying arrival rate, we use schedule. We have to define it. So now we move to the original model. Now we are at step 4. So double-click create one module. The given name is called custom arrive. And then entity type, customer. So time between arrival. So now, because for this particular example, when you have time-varying arrival rate, we don't use random, we don't use constant expression, instead we use schedule. So we use schedule. So which is schedule? You use a drop-down list. There's only one schedule available, which is arrival rate, something we just defined. So click choose schedule and click the right schedule name, which is arrival rate. This is something we just defined. Click OK. Okay, so that's for the first one. For second module, decide. For second module, decide. Double click. Give a name. It's called DR. DL or VR question mark with a two-way by chance. Random. 60% people. I do 60%. So 60% people will go to the right. That means they are looking for driver license service. And 40% people will go down. They are looking for vehicle registration service. So I click OK. Two-way by chance. All right. Now we move to step 6. Step 6. Double click process 1. We have to define the service process. So this is called DL service. Again, it's cease delay release. Add a resource. The resource name is called DL agent. So how many agents we need to serve each customer? It's 1. So delay type, it's a triangular. If you read the beginning of the model, it says it's triangular. As a minimum to serve each customer takes 5 minutes, most likely 10. Maximum is about 15 minutes. Again, pay attention to units. So it's minutes. So 5 minutes, 10 minutes, 15 minutes. That's how long it takes to serve each customer. So it's no longer exponential. It's not normal, not constant. It's something called triangular. All right. Then we move to a second process, which is for vehicle registration. So double click. So give a name. It's called VR service. Action, cease delay release, resource called VR agent. How many? 1. We need a 1. This 1 again is not the number of agents available. This is how many we need for each customer. So again, the service time follow triangular distribution. Minimum 10, most likely 15, maximum 20. Looks like it takes longer to do vehicle registration. Time units, minutes. Again, pay attention. This is not hours, it's the minutes. So it's 10 minutes, 15 minutes, 20 minutes. Click OK. Then you double click dispose one module. This is an easy module. We don't have to do anything basically. We just have to give a different name for informational. DL customer leave. This is a VR customers leave. So DL VR customer leave. Okay, that's it. So this is only for informational. Almost there. Now we have to define capacity. Okay, we haven't defined capacity yet. So go to resource. So right now the default is 1 unit of DL agent and a 1 unit of VR agent. We use fixed capacity. Okay, so this is default. So in the default setting, assume that there's always 1 agent available for each type of service for the entire day from 8 a.m. until 5 p.m., which is not right, right? We have to change it. So go here. So type, let's look at DL agent. Type is not fixed capacity. It's not fixed. It's time varying. So it's got based on schedule. So look at schedule name. So which is schedule? It's a DL capacity based on this DL capacity. Same thing if you look at VR agent. How many VR agents we have? It's not based on fixed capacity. Instead, it's based on schedule. Which schedule? If you do the drop down list, we based on VR capacity, right? That's how we specify everything. Okay, so model is there, save it. Before we run simulation, we have to set up the duration of the simulation, some model parameters. We go to run, set up. So go to project parameter. This is what project, DMB, the DMB project, analyst name, M10, replication. So I'm going to do 1 replication. What's the replication simulation length? I'm going to do 9 hours. As I said, from 8 a.m. until 5 p.m. So do 9 hours. Time units is hours. How many hours per day? 9 hours per day. This one, I'm going to use minutes. The base time units, I use minutes because when I interpret, report, I think a minute is a good unit to interpret everything. Well, nothing wrong if you choose hours, but it's just a little bit unusual. So click OK, save it. Next, it just run simulation, very exciting moment. You can see the queues, right? You can see the queues. Do you want to see report? Yes. So now you can see the average service time is about 12 minutes, less than 12 minutes. Average wait time is about 11.5 minutes. And so we not only see the average wait time, look at here. So we not only see the average wait time, we also see the maximum wait time, right? The maximum wait time. So average customer have to wait for 11.5 minutes. The maximum, the worst is about a little bit over half an hour, 36 minutes. So which is not too bad if you consider DMB. So this is the benefit about running simulation. If you do formulas, we can only calculate average wait time. But if you do simulation, it gives you more information, more detailed information. Not only shows the average, it also shows the worst case. What is the maximum? So if you look at the queue, right, if you look at queue, you see for both DL service, VR service, average queue length, number of people waiting is about 9, a little bit less than 10, at about 11, but the maximum is 28. Maximum 28 people are waiting in line. This is something we will not be able to get from formulas. This is something you have to do it from simulation. So in terms of resource utilization, you can see it's about 93%. For both DL agent, VR agent, average utilization is about 93%, which is pretty full. Okay, pretty full system. So I think I'm going to skip example 8. I don't want to really create a very long video. Everything, all the details are provided in the lecture notes. So what I suggest you to do is you can watch the video, then follow my lecture notes and try on your own. I'm going to close report and the simulation. And that concludes the video.